Hi there, my name is Thomas Randolph. I'm a senior front-end engineer on the code review team at GitLab. In an effort to accomplish this OKR, creating proofs of concept, and in general a focus on performance on the code review team, I've been working on a small little app that kind of re-implements a merge request diff review, trying to make it really fast, really small, really performant. So I'll link the code and the actual application itself down below, but I just want to give a brief overview of kind of the steps that I took to build this and very briefly the technical parts of it. So the foundational premises of this are a performance budget is first, so maximum bundle size, maximum runtime, maximum compile times, just keeping everything as small and quick as possible. That's the first priority for this. The second priority is using platform features as much as possible. So that means browser native storage, browser native component models, and as much as we can leveraging the browser rather than implementing features on top of it in code, which will increase our overhead, increase our runtime. And then events and messages as our command and communication layer. Rather than sort of the drill and execute approach, it's the emit and listen approach, kind of the asynchronous, more whoever cares can respond to this. Things are happening regardless of whether we have direct, implicit, or explicit control over them. So the overall approach, as I just noted, uses sort of events as the binding piece of the application. Events kind of string everything together, and the application logic and the UI communicate over an event system. So that is, the UI is responsible for responding to user input and displaying data, but the application logic, like mutating data or storing data or retrieving data, those things are separate, and they're communicated over events, and they are handled separately. On the UI side, to keep things small and light, there's zero VDOM, so no JavaScript overhead. And for component level state, like loading states or error states, uses finite state machines to transmit or to move around those states. There's one small developer experience indulgence here using the lit library to wrap around the browser level component model. We don't have to do that, but it is a very, very small library. I think in the single or very small double-digit kilobytes, maybe 12 kilobytes, for a little bit of a nicer experience, kind of the traditional component model that you would expect with lifecycle events and that kind of stuff. So a little bit of an indulgence there to make it more fun to write those things. On the application side, for application state, essentially using local storage, so tokens, authorization codes, the type of things that you want to persist in an application but aren't necessarily permanent, local storage. For the types of data that are permanent and persistent, so for example, one of the ways that this application is extremely fast is it accesses things that you have visited before from local storage or from IndexedDB first. For those persistent things, IndexedDB is where we go first. When we can't get IndexedDB, we reach out to our actual API, and that uses sort of a RPC-esque architecture where a single call is made, which reaches out to our backend server, and then that reaches out to the GitLab API, wrapping multiple REST API calls into a single RPC, which is fetch this MR, and that results in multiple API calls. One small developer experience indulgence here using the Dexy library for IndexedDB. IndexedDB is extremely powerful, but the API for it is a little gross. So Dexy makes it much, much better. So a little bit of an indulgence there to make that more fun to work with. So overall, the application uses mostly native features of the browser, with a few small indulgences like lit and Dexy to make certain things easier, and splitting UI concerns, rendering, away from application logic using the event system. So I hope that gives you a brief overview of what the microcode review app, how it works. And if you click the links down in the description, you'll see how it works and feel how it works and feel how fast it is and what we can accomplish with these techniques. Thanks.